let us welcome you on the fourth ETN training webinar. Today we will learn, as you've already heard, how to handle our telemetry data with ETNR package. Our presenters, Peter and Damiano, will guide us through the process of analyzing, publishing, and visualization of the telemetry data. My name is Maria Prchalova, and together with Renanel Pigholz, you can locate him somewhere, we lead Working Group 4 Training and Knowledge Dissemination of the European Tracking Network Cost Action. So today's webinar will be presented by two experts in telemetry data analysis and developers of our packages for ETN database, Desmet and Damiano Oldoni. Peter and Damiano are backed up by ETN database squad, including Jan Rubens, Aubry Noyes, Bart van Hoorn, and Caroline. I miss her surname. I'm sorry for that. Let's say something about our today main presenters first. Peter Desmet is passionate about open data and open science. He works as an open data coordinator for the Open Science Lab for Biodiversity at the Research Institute for Nature and Forest, INBO in Belgium. As a biodiversity informatician, Peter writes software and documentation, publishes open datasets, develops international standards to share biodiversity information. He also coordinates the development of research infrastructures with a focus on animal movement data. Damiano Oldoni works as a research software engineer for the Open Science Lab for Biodiversity hosted by the same institute where Peter works, Research Institute for Nature and Forest in Belgium. Damiano's mission is trying to create order in the world of taxonomy, indicators and alike. He does so by writing open and documented software in R or Python to help his colleagues to speed up their research. God bless guys like him. He is one of the initiators and promoters of the INBO Coding Club, which is a peer learning R group. The webinar will have the following agenda. At first, we will be introduced to the ETN package during approximately 20-minute presentation. Further, we will set up and install the package. Once we all have the ETN package successfully installed, guided hands-on session in ETNR Studio will follow. At last, we will try to publish and submit our data to Marine Data Archive. These steps are scheduled for approximately 2 hours, but you can expect some short break. Whenever you have a question or comment, please raise your hand using emoji button on the bottom of your Zoom screen. Can you locate it? It is under Reactions menu. I hope yes. And me and Renanel, yes, thanks, Gloria. Me and Renanel will do our best to keep an eye on raised hands, and Silvio, thanks for confirmation. Me and Renanel will do our best to keep an eye of raised hands and moderate the discussion by calling questioners in order of raised hands. Luckily, Zoom displayed the hands in the order they were raised. Once your question or comment is answered, please lower your hand using the same button in case we will not manage to do so. You can also send your question or comment via Zoom chat. Please address it to everyone in the chat. And please use the chat as a platform for questions, especially during the introductory presentation. Yeah. Can you locate the chat button? It should be again on the button of your Zoom screen. Yes.
Yes.
Okay. Lovely. Lovely. Okay, and we intensively encourage you to ask as much as possible. Maybe you know this Chinese proverb, which says, a person who asks a question may appear as a fool for 5 minutes. On the other hand, a person who asks no questions stays a fool forever. In case you want to communicate directly with another participant of the webinar, select their name from the drop-down menu and send your message privately. Please note that this account, the Zoom account we are currently using for this webinar session, also saves the private chat messages, but no worries. Organizers, either account holders, will not access private messages for any purposes. The webinar is recorded, and its recording will be uploaded to the ETN YouTube channel. We will notify you via email once the recording is ready for review. And we are pleased to see that this topic is of great interest for so many of you. We have more than 120 registered participants, and right now I can see around 60 already connected attendees. It's pretty great. And this is all from my side, and now we can proceed to our package introduction. So please, Peter and Damiano, now the stage is really yours.
Thank you. Thank you for that introduction. So yes, I'm Peter, and this is Damiano. You mentioned that we are experts in telemetry data. I would say that is not really true. We have worked with the ETN database and developed a package to access the data, but we're not telemetry researchers. We're research software developers, and we're trying to make that connection and provide a tool so that researchers can access their data and publish their data as open data. So if I say foolish things in this presentation, that is because I've never held a fish with a tag. I'm only looking at the data and the software. So on the management, visualization, and analysis of data in aquatic telemetry. Let's see. There's the ETN application, which is hosted by Bliss, which of course holds a lot of the European tracking network data, and where you can log in to access your data and data that is not under a moratorium. You have different scopes in the application, which is something new. So you have a scope for acoustic telemetry, for seapod data or underwater acoustics, archival data, and acoustic archival data. And under the hood, there's a new model to actually hold all that data and to actually share the resources that are shared between those different scopes, and to have separate entities for where there's something very specific. And I want to kind of explain a little bit how that model looks like in the database, and also how we've modeled functions around it in the ETN-R package. The archival data are data that are actually stored by the tag and then can be read out if you retrieve the tag. So you have animals, which are grouped under animal projects. So each animal is part of an animal project code. It has a scientific name, of course, and a tag serial number. And that tag serial number has tag properties, and associated with that tag serial number, you can have archival readings, so readouts of the sensor data that is collected by the tag. Then a bit more complicated is acoustic telemetry, which is how ETN started, where you again have these animals. They have associated tags with a tag serial number, but those tags have their own acoustic tag ID. This could actually be more than one acoustic tag ID, which they use to broadcast where they are. Those are then picked up by receivers, which you can see all the way on the right, and those then generate acoustic detections. Because acoustic detections are the main bulk of the information that you want to access, we immediately associate those to an animal project code and a scientific name, but not all acoustic detections are associated with an animal. There's also acoustic tags that are not associated with an animal, such as sync tags and sentinel tags, that also generate detections, but are then not associated with an animal. Within the acoustic detections, the way you know which tag it is because of the acoustic tag ID, which you can then use to associate with what tag it was and if that tag was associated with an animal. On the other side, you know that an acoustic detection is detected by a receiver at a certain station name. Those receivers are deployed in what is called network projects, but we've renamed that to acoustic projects. So these acoustic deployments are receivers that could be deployed over time with the start and end dates and can be reused as well. And if you want to know what receiver was used and the information for that, that is in the acoustic receivers table. So here again, you have this animal projects, which is a way to group animals and have ownership of animals and the associated information. And you also have this acoustic or network project, which is a way to group deployments into basically a sensor network that can pick up tags, acoustic tags passing by. And then finally, you also have the CPOD data, which is for the acoustic network to the citizen passive acoustic network. You also have receivers that are deployed in what we then call CPOD projects rather than acoustic projects. And they can also have detections, but these are not detections of tags, but detections of acoustics that are recorded, as far as I understand. Now, the ETN R package is an open source R package, which is developed to allow researchers to access all that data that is available in the ETN database and that you can access through the ETN application in workflows that you actually use to analyze the data. So rather than having to browse around on the ETN application and download data, you can access the database directly with the ETN R package. It is available and it has an associated website at inbo.github.io/etn, where you also have a reference of all the functions that are available in the R package. Because the model of the ETN database changed recently, we, in the last 2-3 weeks, did a big kind of hackathon or like a sprint to make sure that the ETN package is back up to where it was before with the old model. We have a whole number of tests to see that the functions work as expected. But since we had to do a bit of a rush job, it is possible that there are still issues, and it would be very nice if you could report them. There are also still a couple of functions that are missing, which we will add in the near future. For each function that you have in the package, you can have documentation. For example, here is the get animals function, and it will shortly describe what this function is, what the parameters are, and it will also provide examples on how to use these parameters and what results you can expect. The source code of the ETN R package is open, so it's an open source R package, and the GitHub repository is where you can find everything. And this is also where you can submit feedback, which is done in GitHub issues. There's currently a list of open to-dos and questions regarding the model. So it is still in progress, but it is open to everyone. So if you have a question, and some people already have submitted questions or reported bugs, that is the place to do it. If you want to be notified of the discussion here, you can click the watch button, which on this screen says unwatch because I am already watching it. And you can select this to only be notified if your name was mentioned or if you want to be notified of everything. The environment in which the R package works is the RStudio LiveWatch, and the reason for that is that the database connection is not publicly accessible. You need to be within the same network to access the database. That is a security measure that Police has implemented. So that means you cannot use the ETN package, unfortunately, on your own local RStudio. You have to log into the rstudio.livewatch.be. That is something I would like to change in the future, but that is not going to change until we have web services with which we can connect to the database in a more secure way. So for now, all access to the ETN database with the R package is on the rstudio.livewatch.be. Then how the functions are organized in the R package, how the functions work, we will show in the next section. That is what Damiano will show, where he'll go to a whole tutorial. But it is basically organized as the model is organized. So for the archival data, you can use get animals to get information about your animals, then get tags, and then there's get archival readings. That function has not been implemented, but that would be downloading or having a list of all the files with the sensor data. For the acoustic telemetry, all the functions are implemented, and that is the one we will discuss in the hands-on tutorial, where you basically be able to access your animals, tags, acoustic detections, know how to filter those, know which deployments are associated with it, and also the receivers. For the CPOD one, that is something that we want to implement very soon, but for the moment only the get CPOD projects is implemented to get access to the receivers, deployments, and detections. That is yet to be implemented, but we hope to do that very soon. That's it. That's a very short introduction to the model and the R package and the design choices and how we develop it. The package website is, as I said, inbo.github.io/etn. The application is one you already know. And the RStudio link is there as well. For any questions regarding ETN, you can use the email address etn@livewatch.be. I'll now switch back so I can actually see all the participants and if there are any questions.
So please, in case you have some question regarding this this introductory talk, please raise your hand.
Yes.
Yes, hello. Thank you for this overview. Again, you mentioned that the access it's now exclusively RStudio. You can access with base R, is it?
No, you cannot access the ETN database from your own local computer, unfortunately. That is correct.
But also it's needed to use everything through RStudio. Some people still a few, but some people are not using RStudio. This is a problem here, is it?
Yes, I think the only way you can access the database is through the RStudio server that is hosted by LiveWatch. So if you're using, if you are not using RStudio, whether it's not using RStudio on your computer or using it, if it's on your local computer, you will not be able to access the database because the port to the database is not publicly over the internet accessible.
So if I may add here, it's correct what Peter says. So you can only access your data directly from the database through R. But if you're not familiar with R, there is still a possibility to download your data either from an R Shiny application where you can filter. So you also need to log in there. You can filter your data and click the download button, or you can do it directly on the front end in the ETN database where you manage your data and metadata. There you also have the possibility to do download. Of course, this is an extra step because you first need to download and store locally and then start accessing your data, while in R you can do it directly. But I'll just add the link to our Shiny in the chat, and that's also a way where you can get.
Okay, thank you. I was just distinguishing to use R without RStudio. Okay, thanks.
And then, as you just learned, we've got Jan Rubens here. So in case you have a question directly to ETN, please, he's the ETN chair. And also, Junpei has a first troubleshoot here. So he tried to sign up for our RStudio, but it seems that it's solved by now. Am I right, Joan?
Yeah, I got a generic error that was a little cheeky, but it was just because I already had an account.
Okay, so avoid being spammer, right?
At least call me a hacker.
We will.
Okay.
So another thing I would like to mention is that with this update of the R package to a version 2, we've made some design decisions that we hope are intuitive for users, but any feedback on that is also appreciated. So we've split a number of functions into like the scope they are used for, whether it's archival or acoustic or CPOT. But yeah, we'll only really know how useful that workflow is if we hear from you, not necessarily during this call, but afterwards, if you're using the package, feedback on the design of the package and how functions are organized is appreciated. I don't see any further questions for the moment. So then maybe we can move on to the most tricky session or section of this webinar, which is having people trying to log into RStudio and load the package. I'll give the words to Damiano for that. I hope someone who is on standby in case there are any issues.
Yes. Hello, everyone. Do you hear me?
Yes, yes, clear and sound.
Great. First of all, I want just to add the fact that as we have ETN version 2, let's say, that means that if you have used to use this package before, before the database model changed, then you will not be able to use the same function as it was before, as this because the scope has been increased, so some function changed their names. Peter did a great job as a maintainer of this package to allow people to not be completely lost. So some functions are deprecated, and you will get notified of this change of the function names. Okay, so I think I can start presenting my screen. Do you see my screen? Okay.
Yes.
Thanks. First of all, let's try to have everybody set up with login, credential, password, whatever. So as Peter Desmet said, we need to have access to a studio server, and that's something I hope it works. If it doesn't work, please write in the chat. Fleece is listening to you, and they will try to get back to you. There's a second password credentials needed, and that is to access to the database within the RStudio server, so to make a connection to the server. So this is how it looks if you have access to the RStudio server of Fliss. Here you don't have any connection. You can start by installing the package.
Damiano, maybe I will wait for, let's say a minute to allow people to enter the RStudio, because so far I haven't noticed any successfully
Okay.
Eureka's and hoorays for people getting in.
Yeah.
So guys, please let us know that you are not there. Remain silent if you are there.
I'm not there. I'll go ahead and speak up. I got to a forum where it asked me to extend my account to get our studio access, but now I don't know if there's a human step involved in getting the last step of the way.
Indeed, there is a human step involved from IT of FLIS. Will let's say guarantees that there is no spam emails and so on. There is a human step in this involved. So please, yeah, be patient. That should be solved by FLIS.
Excellent.
Yeah. Meanwhile, I would just say that in the future there will be an improvement about this. FLIS is trying to move to a better system where you have not to deal with this multiple series of accounts and passwords. We hope as well.
Sorry, can I just ask a question? So the credentials to log in from the RStudio interface are the ETN credentials, is that right? Or is
No,
it different credentials? Okay.
Different credentials.
Okay.
I wanted just to mention it. Yeah.
Actually,
No, so just to be clear once more, so actually there are 3 different credentials. One, to access the ETN data system, the front page where you can manage your data, the metadata. One, to get access to the RStudio server. And then the third one is to link your account on the RStudio server to the database. So it's not because you registered for RStudio that you can already access the database. Then you need an extra password to do this linkage. Yeah, so Peter just put it in the chat. And it's this third step that is this human interaction. So that someone of our IT will provide you your credentials. I know it's a bit of workaround and we are working on this to improve it, but for the time being, it's like this.
And so at all times, you need to be signed in with all of those credentials. So you have to sign in into the ETN application before, no? Or you can just, okay, right, thank you.
if you are working indeed in RStudio server, then you don't need to open the web site where the web portal, let's say. So you need just the 2. I will show you here what we did the last days, let's say, and how you can do it later on when these problems are solved. So let's say that so now you see the vignette, the tutorial that I wrote for this 1 hour. First, you load the ATM package. We need some other packages to make some data analysis or data visualization. So usually we use dplyr for data science, filtering, selecting columns, grouping, summarizing, and so on. Lubridate is a package to handle date times in a friendly way. And leaflet is to make interactive maps instead of the typical ggplots and so on. We will see at the end of this tutorial. Well, this is how you can install it, let's say, and load these packages. Nothing very new. This is what I told you just a few minutes ago, how you can, so if you click here, you see how you can save things in a safe way using the .renviron. It stays for R environment, of course. So in this way, you can always have the user ID and the password that you got from FLIS to access the database, always as a user environment variables. And you can always retrieve them using sysgetenv here. And when you have this, well, you just save it as a con variable. Con stands for connection, is a typical word to variable name for connections. Well, it's not only a typical way to name a connection, but also the preferred way for us, because let's say if you do like that, you will just go, you have just to forget, let's say, this connection name. You just go further with all of your science and data processing without any problem. As you see here in the first function here, get animal projects, you don't have to mention this con variable because it's the default name for the connection. So please keep in mind that if you give another name to the connection, then you have always to put the connection as first argument of all get functions exposed by this package. Okay, so typically, I suppose we start getting an idea about which projects do I have access to. So I'm a researcher, for example, and I want to start to see which of the projects I'm involved. So I just call generic function get animal projects. And here I show just a preview, my first 10 projects. Of course, it will be different from researcher to researcher, depending which projects you have access to. Notice the project code. It's very important. And the project type, of course, here will be, let's say, always animal, because we are interested in animal projects. If you know the project code already and you want to get details about this project, then you can just call get animal projects, but making the argument animal project code explicit. So, for example, I selected these two projects, animal projects, 2014 Damer and 2015 Dale, that are two rivers in Flanders. And then I save that as a variable project code, and I give it, I pass it to the function get animal projects via argument animal project code. This is what I get. Actually, it's a kind of a filtering. So what they do, what the get animal project does with explicitly mentioning the animal project code argument is in some way is filtering for you from all project code the projects that you are interested to. So as you see, it's exactly the same as doing this. All my project and that filtering based on the project code. There is an interesting function if you just want to a very fast way to get all project code, even the ones that you are not allowed to access. Well, there is a function that we wrote, list animal project code, and this gives you a very long list of all animal project code existing in the database. As you see here, there is a list family. Why? Because you have here a lot of list functions. We will see some of these, two of these later. It's just a way to, but the principle is always the same, listing something and returning a vector. Okay, we are interested to these two projects. As I mentioned here. And the next step is, I suppose, you want to know which animals are involved in this project. So you can use the get animals function, very important function. This function needs a project code, animal project code value. And you retrieve all animals, so all fishes in which have been studied and tagged in doing this project. Here I show a preview of the first 10 fishes. As you see here, there is a lot of variables. So you get a data frame. Tibble here. A tibble is just nothing more than a more elegant way to display data frames, but it's actually a data frame. And you get a lot of information as animal nickname, capture date time, capture location, all capture information, release information, and so on and so on. One thing that can be interesting to do is, for example, with a function count. You can count how many animals for each species. So you can just group them by scientific name doing this. And you can see, for example, there is one anguilla, and so on and so on. And you have 20 Welsh catfishes, Silurus glanis. Okay, so the next step probably it will be, I'm interested in in this species, the Welsh catfish. And for example, I'm interested in the data of 2014. Well, how can I retrieve all detections? There is a function called, not surprisingly, get acoustic detections. This function can allow you to retrieve detections, and you can specify different arguments as the start date, the end date, scientific name, project code. There are others, but so if you want to see all documentation about this function, you can always open it. And here you have, for example, all parameters. For example, I want detections of this species, scientific name, and from this specific receiver, for example, or station name. In this case, I want just to specify the start date, the end date, to have detection from 2014, and the scientific name to have only detection of Welsh catfish. Here, just a fast a preview of the first 10 detections. Again, you retrieve a data frame with a lot of columns. For example, the animal project code, of course, the animal ID to follow the fish, let's say, the receiver ID, the station name, deploy latitude and longitude, quite important to locate the station and the deployment, the sensor value, sensor unit, and so on and so on, signal to noise ratio. First thing you probably want to know, for example, is which individuals have been detected and in which period. So let's say which is the first detection and which is the last detection. So the date, for example, the date of the first detection and the date of the last detection. This I can do it with this basic in dplyr, making a basic data wrangling. For example, I want just the date, not the date time. So I select the date from the date time. I group by animal ID, and I found the minimum date and the maximum date. And here I can show that I have nine Welsh catfishes, and for each of them in 2014 they have been detected with a start and an end. Some of you could be probably more interested to thinking a little different than I thought this, because some of you are more familiar with acoustic tag ID instead of animal ID, because animal ID is just a sequential, is a number given automatically from by the database. What probably you are more familiar with is the acoustic tag ID. So probably you would be more familiar doing this. mutate, and then group by acoustic tag ID instead of animal ID. It's not a problem, as typically the fishes are tagged once. But please keep in mind, if you tag a fish multiple times, I don't know, it can happen or not, but animal ID is the safest way to do it. When you have a minimum date, the maximum date, well, you can always calculate the duration of a tracking. So you can just make the maximum date time, the minimum date time, and you calculate the duration. So in this step here, I do this, and I can, so for example, see that animal ID with the number 365, sorry, has a duration of 173 days, or more or less, and so on and so on. How many times has an individual has been detected? Well, this you can do it by counting the number of detections per animal. So, for example, the fish with an animal ID 365 has been detected almost 5,000 times by the deployed receivers. Let's go to another step of the data processing. For example, you want to know at how many detection stations have individuals been detected. Well, you can, based on detection, you can select for each animal the station names and count them. So you can, for example, know that for the first animal, 365, it has been detected by 16 different stations. Let's say better, by 16 receivers located at 16 different stations. Which station have been involved? Well, you can retrieve them using the function that we developed for this package, list values. It's a quite basic function, which you can see the documentation here. It's a function that, given a data frame, and the column name, or a column, just like you do in dplyr, without the the quotes. It takes the column, takes all the values, take the unique values, and also it can split by comma by default if multiple values in the same row. So this is something that could speed up the development of this package. So we wrote it. So, for example, in this case, you want to have stations directly. You can just you have your detections. You select the station name and you column, and you give it to the function list values, and you get this message that you have the station involved in detections of the West catfish in 2014 has been 23 unique stations, and this is the list returned as a vector. Notice how a detection station can be linked to multiple deployments. So for this reason, I said a fish is being detected not by a station. A fish is detected by a receiver deployed in a certain deployment, which is placed at a certain station. And for example, here you can see that the station DE12 deployment is connected. For example, here you see the station has 3 deployments, indeed, and it's free. D8 is connected to 2 deployments, and so on and so on. Sometimes it's interesting to know the number of detections per station. So you can group it. So you have always your detection values. You group by stations and you count it. So this is all detections. Doesn't matter from which the fishes are. With a detection linked to this station. Something also interesting to do is to know the number of unique individuals found per station. So here, for example, you can see that at the station D1, the receivers have detected 3 fishes of this species. We're always speaking about West catfishes. DE10 detected 6 fishes, and so on and so on. This is something is basic data science that I use dplyr to do it because it allows me to write it a code that is quite readable by everybody, I suppose. So again, you take your data frame, you select your columns, you want distinct values, unique values from them. And then you group by station name and you count the number of rows for each station. This way you have the number of unique animal ID linked to each station. Another chapter of the ATN package is retrieving information about acoustic tags. For example, here, let's say you want the tags from this detection. This is something I could do actually with list values as well. Once you have your tags ID, unique tags ID, you can just use the function get tags, and using the argument acoustic tag ID. In this way, you get information about all tags used to track fishes involved in the detection data frame that we saw above. This is just you have 9 fishes, and indeed, in this case, have been tagged once, as usually occurs. So you get 9 tags back, and you have a lot tags data frame returns a lot of columns. You see here you have 44 more variables. That means 44, 45, 46, 7, 8, 9, 49 columns. With all information that you have, and you could be interested to know about any tag. For example, the battery estimated life, the model, the manufacturer, the frequency it works, the sensor range, accuracy, and so on and so on. You can also retrieve this information using the tag serial number. That is another parameter that identify a tag. So you can do the same using get tags. Tag serial number equal tag serial. And you get actually the same table back returned. However, keep in mind one thing, that there is a fundamental difference between acoustic tag ID and tag serial number. The tag serial number identifies the device, which could contain multiple tags. That's also very important. Tags of sensor. And so you have multiple acoustic tag ID. So this is the biggest thing to remember, to keep in mind. Tag serial number applies also for not acoustic tags. Right? So as we wrote here, sensors. Okay, this is quite important to know. You can list all acoustic texts you have. We just made a preview of 10 because otherwise you will get a lot of them here. So with in the list family function, you have this function called list acoustic tag IDs to retrieve all of them. Okay, once you have tags, one thing you can be interested to know is which are the acoustic network projects involved in my research. So which deployments have been are involved in my research. Well, again, with the list value help function, you can retrieve them. So based from detection values, you can know this by specifying the column acoustic project code to get the acoustic network project codes involved. And you see that you get these two. So these are two acoustic network projects. If you want to know more information, as we did for get animal projects, you have get acoustic project function. And in this function, you can specify your acoustic project codes to get more information about these two projects. Again, there is a list function if you just want to know all acoustic network projects in the database. Okay, let's say that now you have detections of Welsh catfishes. We have acoustic projects involved in these detections. You want, for example, to know which deployments have been deployed for these networks, for these two networks, these two, Damiano and Zishelde, in general. Welsh catfish or not Welsh catfishes, doesn't matter which deployments have been deployed. Well, you do it by applying get acoustic deployments function and passing the argument acoustic project code, passing acoustic project code, so the vector with the two projects, to the argument acoustic project code. And here you get all deployments, so a data frame with 371 lines. These are all deployments involved in these two networks. Other way around, let's say you start from detections. You have your detections of Welsh catfishes in 2014, and you just want to know which are the deployments specifically of this detection data frame. Well, again, with list values specifying the column deployment ID, you can get this. And you get a vector of all deployments, see here. More information, so this is just a vector. Again, if you want more information about them, you can again use the function get acoustic deployments as we used here. But instead of using specifying the argument acoustic project code, here you specify the argument deployment ID, and you pass to this argument the vector with all deploys involved in the detections of Welsh catfishes. And here you get 33 deployments, specifically for the detections we were under observation here. Well, something that you can be interested to is to know the deployment duration. Again, it's a little data wrangling, data transformation, data science. Again, with S duration, I can recover the duration using the recover date time and deploy date time. So I get a duration, and then I select these three columns just to show them to you, and arranging them by deployment ID. So I know that deployment 1378 at station D7, DE7, had a duration of more or less 32 weeks, and so on and so on. Keep in mind that if a deployment is still ongoing, then duration is NA. Why? Because you don't have a recover date time. So the deployment is still there. The receiver at the deployed in this deployment is still there. It has not been removed. So recover date time is not available. So the duration is still not available. So once you have a duration, you can probably know, also you want to also know the number of days a deployment detected the passage of one or more fishes. So what we call probably the active days of a deployment. Again, you do the small pipe of data transformation. You get the date from the date times. You select the deployment, the station name, and the date. And you make them unique by distinct, and you group by the deployment and station name, and summarize to get the number of days, and you get actually this, where you can see that the deployment 1378 at station DE7 detected one or more fishes for 125 days, and so on and so on. For all deployment ID, you get this information. Just one note why I show the station name together with the deployment ID, just because personally I know the station name is something quite familiar. You are familiar with. Deployment IDs are just numbers IDs you get back from the database. So it's I like to have station names always when I do this kind of data processing, just to know, okay, I deployed this at this station. Once you have the duration of a deployment and the relative detection duration, you have a number of active days of a deployment, then, well, it's easy to know the relative detection duration. So, so a percentage, let's say, a number between 0 and 1 to show how effective was this deployment. So you get your number of active days, you join with the deployment duration, and then you can calculate the relative detection duration by calculating the number of seconds of, so actually the number of days that you got here, you see, multiplied by the number of seconds in a day, divided by the total duration of the deployment. So the duration here, the duration, as you see here, it's of type duration, is something that Lubridate package provides you to handle dates and date times, in this case durations. So as you see here, durations are always in seconds, but let's say they're of a class duration. So to make them available as seconds, as integers, as numeric, then you have to do this as numeric. You have to wrap the duration with the as numeric function to retrieve them as seconds. So now I can do this the division because I have seconds divided by seconds. That's good. So I get the real relative detection duration. Okay, so I can say at the end of this pipeline that the deployment ID 1378 at station name DE7 had a relative detection duration of more than 50%, so 0.548. So that means that more than 50% of the days, let's say, there was one detection. That's quite a lot. And now last step of this example of what you can do with ATN package and what you can do with the data you get with ATN package, some data visualization. You can do a lot with ggplot, of course. You can all of the information about, for example, let's say duration or whatever you have before. I think you can do it with ggplot to see the number, for example, of fishes detected at each station and so on. But here I want to focus on what you can do more than basic histograms or scatter plots. Well, telemetry data is by definition something which allows you to make maps. No, you have geographical information linked to this telemetry data. So I like to make maps, interactive maps using Leaflet. This is a quite good package to do this. First, for example, let's say, for example, first we want to create a map of involved stations, showing the station name, the acoustic project code as pop-ups. This you can do it, yes. First, from the detections, you can get the station name and the latitude and longitude of a deployment and the acoustic project code. You get this, and you save it as a data frame called GeoInfo station. You can see, for example, for this station DE1, you have this acoustic project code, and it is at this latitude 51 and deploy longitude 4.84. To be able to produce the desired map, then we use Leaflet applied to this basic data frame here, GeoInfo station. Well, what you have to do is just providing this to a function Leaflet. Adding the tiles means just adding the OpenStreetMap's background. You can specify, of course, different tiles, but this is out of scope here. And you can add markers, specifying them at which longitude and latitude you want them. In this case, you want the longitude at deploy longitude and the latitude at is deploy latitude. And the text to put in the pop-up here is the station name, and then within brackets, I want the acoustic project code. This is just an example I give you. Feel free to modify everything and to make your wonderful maps. Another things that I want to show you what you can do with Leaflet is to visualize the number of detections per station. So we had, if you remember, we had the ndetect station data frame calculated before. I can just here, you see here, ndetect station. This was a data frame with station name and the number of detections per station. Okay. How to do it? Well, you create your continuous color palette function. I use Viridis, that is colorblind palette. So I suggest you to use this a lot. And then what you can do, of course, first I have to add to this data frame the geographical information that I retrieved just a minute ago in GeoInfo stations, and then apply Leaflet, add tiles, and in this case I want not just markers as here, because I cannot give nicely colors to this. I just use add circle markers. I want circles, and I make these circles again at the same longitude and latitude as before, but I add radius argument and color value argument. The color is defined via the palette, so the color function here, based on n stays for the number of detections, and the radius, I use the logarithmic value of n in logarithmic scale, just because otherwise you have are very, very small and very, very big circles. In this way, you give an estimation of the detection by an order of 10. So in this case, you can see here, and then I get also a pop-up in different lines. So this is HTML because Leaflet is developed in as HTML as Java, and use HTML. So you can just paste this information using as separator this strange delimiter that is nothing else than saying to R make a new line in HTML, and then for each line I want in the first line I want the station name, the acoustic project code, and in the second line I want the number of detections, and I get something like this. So you can zoom it, of course, because it's interactive maps, and you get this. See here. All right, the very last visualization I want to show you before concluding this tutorial, this session. Well, this hands-on session without not a lot hands-on, but it's this kind of visualization. We spoke about also the number of detected individuals, similar to the previous one, and is this okay? But I want to, it's actually the same, just you get this ancillary station instead of end detection stations. But what I want to show you is this one, the relative detection duration. Maybe you are more interested too. We calculated the relative detection duration of each deployment. Well, you can again, you can add geographic information, practically the same as we did before, using the same columns, deployment ID, latitude and longitude. We add this for the pop-ups in the map, and then we do actually more or less the same using this relative detection duration. Again, we join with the geographic information to get it. Here, I just relative detection duration is a number between 0 and 1 to make the radius of the circles quite understandable. I just multiply by 100. The color is always defined by the palette function I define here, beginning. And add a legend again as the same, and this is what you get. So this is the deployment ID 1379, station S2A is held, and you get the relative detection duration 0.03. Here you have 32. Notice how Leaflet cluster your information. If you give this parameter, this argument, cluster options equal to Markov cluster options, this way you cluster your information, and you can zoom on it, and then they are split it. You see, you get 13, 2, and you get the 2 here. And again, if you zoom out, they are clustered back. This way, you don't have too many points, too many circles at the same place in a map. I think this is all what I want to show you, what you can do. Well, the last thing that I want to say is that if you want to add the temporal components to visualize fish telemetry data, well, you can just give a look to the Move This package. It's a package where you can create interactive maps, let's say, and you get these things here. I wanted to try to not to make the tutorial quite contained, let's say, but this is something that you can also use if you want to improve the tutorial. If you want to improve this package, feel free, please. It's open source, so make a pull request, make a request changes. This is, as I said, it's open source, so it's software by everybody for everybody. I can stop sharing my screen, and there are some. I couldn't see the chat. I hope that will be moderated quite well. Thanks, Peter, to do that. There are some other questions I can reply.
I believe Damiano, once you unshare your screen, you will see the chat. Yeah, and thanks, Peter, for managing the chat. It was really helpful, I must say. Yeah.
Thanks.
So there's two aspects that I have corrected, which is the get animal projects is all the projects. I have corrected that. And to be able to filter detections on a date, the end date is exclusive. So to get data from 2014, you have to do 2014-0101, 2015-0101. If you reload the tutorial, you will see that it's already correct.
Thanks.
Yeah, I must say I enjoy the leaflet function. It's really amazing. Thanks for that.
Yeah, welcome.
So,
yeah, something that typically is not shown in documentation of packages because yeah, it's something out of the scope. But I think it's always nice to see what you can do with data from the beginning to the end.
So guys, I think that we can officially start the discussion part. So please ask.
Okay. Can you show us what kind of data frame you've got at the beginning, please?
Mm-hmm. At the beginning, what do you mean? From detection or from
the kind of data you work from?
Well, I start from, so I connect to the database and I select these two projects, animal projects here.
Okay.
And I get the animals of these two projects here, get animal projects, get animals, see here. So I get these animals and I see that there are different species. And then I say, I want detections of Welsh catfishes, Silurus glennis, in 2014. So I just do this. And then I go forward with detections. It's just an example.
Okay.
But I think the workflow, I think that researchers start from an animal project, because usually they start an animal project. They start tagging animals in the fields, they're participating in a campaign, and then they want to retrieve all information of their animal projects. So for this reason, I started from animal projects to get things done.
Okay.
Okay.
Thank you.
Welcome.
And maybe you noticed that Jan pasted a new link to ETN RStudio during Damiano's talk. So maybe it's corrected and adjusted by now. Yeah. So afterwards, maybe you can try to log in.
Yeah. So indeed, I added a new link. So normally, if people got their credentials to access the database, there are two links. So you have the rstudio.livehatch.be and you have one with the .vsc in it as well. It both directs you actually to the same environment, but it's working on a different server. So the second one, which I posted, I'll post it again so that you don't need to scroll the whole chat again. Normally should still have a lot of space. Why we had no space left on the device is because one of the ETN users not present in this webinar was apparently doing some analysis, which was taking a lot of memory. So probably, I don't know, maybe he was working with the entire ETN dataset. I don't know. So next time we make sure that no one accesses ETN if not in the webinar. But actually, so the other server should work fine, and there we still had a lot of space, so they did some checks. But I'll post the link again.
Yeah, I've also to say that I never had this problem. So I mean, this is doing a very good job to do this and to maintain this infrastructure. And indeed, I never had this problem before. So I mean, it's quite stable. We could develop the new version of this package without any problem in very short time, let's say. So yeah, I have to say that because otherwise it seems that nothing works. It's not true. Thanks.
But and once again, as we mentioned, we are working to ease this way of accessing the system. So we hope to have something on CRAN in the near future, which will make things much easier.
Okay, sorry, can you hear me now?
Yes.
Okay, great.
Yes, yes.
So we have actually built a function in the R package where you can download all information related to a project. So getting the data out of ETN to publish it is now provided in one single function called download acoustic dataset. And what you need to provide is the acoustic animal project code, which you have here. And you can also filter on specific scientific names if you want to publish only a subset of the animals in your animal project code. And what it will do is it will go and look using get animals, all the animals from your projects. It will look for all the associated tags with those animals. Then it will search for all the detections that are associated with those tags. And then to have an ID of the receiver network that is out, it will look in those detections what deployments were out and to which acoustic networks those deployments were associated. And it will retrieve basically all the receivers from those networks. So you will end up with 5 files: your animal CSV, your tag CSV, your detection CSV, your deployment CSV. But do know these can also be deployments of networks that you do not manage. If your animal was detected on a network that is not owned by you, it will end up in deployments. And then all the receivers associated with those deployments. There's also a 6th file called data package JSON, which is basically a metadata file describing the structure of all these tables. The whole package itself is structured as what is called a frictionless data package, which is an international standard to publish CSV data in a structured way. So the data package JSON is going to say what the data type is of all the columns and what the identifiers are and how they relate to each other within between all those files. So if you run that file, and I'm going to try here live in our studio, which we shouldn't do, but I'm going to try it anyway. You will see here that it is, I'm downloading data for the 2014 Damer animal project. It's going to output to the terminal saying, hey, yes, I'm now downloading the animals, so the 5 files, the tags, detections, deployment, receivers, and adding that data package metadata file. And it's also going to provide you some metadata of that project. So I apparently have 16 animals, luckily only 16 associated tags, so there's no double tags. The number of detections, deployments, and receivers, the first and the last date, the included scientific names, and the included acoustic projects. So the warnings that I'm getting here at the bottom is because there's no space left in the device. It will also warn you if in case there's an animal reused, sorry, a tag reused for multiple animals, or if a tag is, or if an animal is associated with multiple tags. All that data is then in a folder that you can download. So if I go here to this one, and I click more exports, I will be able to download that full data set to my computer. And then the next step is that you can contact Etienne at livewatch.be to deposit that data set with enough metadata on as a marine data archive. And we have done that for LiveWatch with a number of projects. I will link I will post the link here in the chat. But we have all these projects, the data is publicly available. So for example, for the 2014 Damer one, there is an associated DOI that will be brought here on this page where I'll have all the metadata that you have to fill out together with the maintainers of Marine Data Archive. And as you can see, it has a citation and it has a DOI to reference this data set. And users can download the data by clicking this button here. And as you can see, that then downloads the data set that I have previously published. So this is a great way to actually publish a data set that is a bit locked into the Etienne application. If you're, for example, writing a paper and you need to have the associated information or data published as well, is to publish that data as a marine data archive. And you can now do this with this single function. Of course, the more detections you have, you might it might take a while before everything is downloaded, but the function is designed to package everything up for you. And so the only things that you still need to do is then upload it and work with the maintainers of the Marine Data Archive to assign a DOI and have sufficient metadata so it can be published and accessed by others. Jan, do you want to add any information to that?
No, I think you covered most of it.
You're currently muted, it seems.
Can you hear me now?
Yes, we can hear you.
Okay, sorry.
Okay, yeah, no, nothing to add, Peter. Good explanation. I'll just add a link in the chat again if you have questions related to DUIs and what it is and how it works. There's specific people you can contact there. But I think the functions you just explained do an amazing job to ease it for us to have this created.
We have here another thank to Damiano and Peter for well-crafted package. Great resources as well.
Thanks.
It arrived from John, sorry.
Well, we hope that after this introductory webinar, people will be able to log into the RStudio server. I mean, we're convinced that the issues will be resolved, and then you can explore the package yourself. The package website, all the functions are documented, so you should have all the material to start using it. And again, if you have feedback or questions, the issues in the repository, you would need a GitHub account, which is free to make to be able to post issues, or you can contact Etienne at livewatch.be, and those technical issues will eventually reach us.
Yeah, we really thank you guys for spending time with us today. Yeah, we've got some difficulties with RStudio, but I think that anyway, this package of yours or the Etienne package is not an easy task to be digest within an hour. So it would deserve more hours, and I believe we will return to this during training school, hopefully next year. That can be organized in person. So take this like a light invitation for the next year. So we will get in touch more with this package during the Etienne training school. And I guess that you plan another packages for example, pit telemetry data?
For which kind?
Or another type of telemetry data ETN is going to be accustomed to, like pit telemetry, for example?
We hope to make sure we can cover the different tracking technologies in ETN in the future. Of course, it all takes some time to adapt the database, and then, of course, later on the package as well. But there's still a lot of things we can develop. And of course, suggestions are welcome, because it's also based on user feedback and user requests that we plan specific developments. So all feedback welcome there as well.
Great, great, yeah. Sure. it's straight, you know, answering the chat messages like this. Okay, guys, are you having anything more in your mind you want to share with us right now? If not, I guess that we can say a big thanks to Damiano, Peter, and all the ETN database squad, including Jan and Caroline, Bart and Aubrey, and probably Leonard in the past, as far as I understood. So thank you all again for your great job you are doing for all of us. Yeah. So thank you, and see you soon, or meet you soon.
Yeah, thank you all very much.